So, and I think I'm really thankful to give this opportunity to discuss the software quality assurance with the MCS students as well. Okay. So before we start, so let me introduce myself as well. So actually, I have been working in this industry last 20 years. So, and mainly last 18 years, I was working in software quality assurance. So the Exactpro is I think one of the latest organizations we have set it up in Sri Lanka. So actually, we are based on UK, and so this is the very first software testing services organization set it up in Sri Lanka in last year. So before that, actually, I was in one of company that's probably you might know about the Virtusa. So I have been working from the Virtusa last 18 years. So and running the quality assurance, and I has been practicing for some of the divisions in Virtusa last few years. So that's all about me. So let me share my screen first. Okay. Hope you all could see my screen, right?
Yes, we can see.
Okay, great. Okay. So basically, during these 3 sessions, these are the few areas what we are thinking to discuss with you all. So one is probably the today's session, we will give an introduction to the software quality assurance and the quality engineering. And the second session, so basically we will use the Q quality assurance techniques and software test automation, and how we are going to use the automation in real world projects. And the last session mainly on the quality management and what are the latest trends that we are in front of us right now with the in the software development industry. So those are the 3 areas that we would like to discuss with you all. So whatever the questions that you have, I think you could be able to ask whenever when I'm having the session with you. Either you can use chat or you can share your question. So we would like to actually have a live session, so interactive session. So because these are, and I'm trying to discuss a few industry case studies, actually what we have faced in the industry, and even from the real very latest case studies. What because of that, I'm pretty sure that those will be interesting stuff. So please feel free to ask questions. I know that usually when we are doing the sessions in Sri Lanka, what we have noticed is many of them, even we are reluctant to ask the questions. So I think one of key challenge what we have noticed in the Sri Lanka has, so for that is actually even challenge for our grow in our industry as well. So I think don't hesitate to ask questions. I think there's nothing called wrong or right questions. Every question should have an answer, and we should taken care of. So because of that, don't worry. There's nothing called wrong or poor questions or anything like that. Every question, there should be a value, and there will be a reason to ask. Right? So because of that, don't worry to ask questions. So that's the one thing we would like to request from the beginning. So if you couldn't answer, even you can use the chat. So because we are using the online session today. So, okay. So before moving to that, so I just want to just brief. So the software industry is one of the latest industry, I think, that you all know. Probably you all working right now in the software industry as well. So by the way, anyone has quality assurance experience previously, or anyone working on in this quality assurance field as of today? Even you can use the chat and say whatever your answer. Okay, no, okay, no answers. I think okay. So if I just asked because
somebody raised the hand. I think Haslam.
Oh, I think I could not able to.
Yes, ma'am.
Okay.
You can provide the answer, maybe.
Yeah. So currently, I'm working as a senior test automation engineer. So I just started my career in 2017 as a QA engineer. So it's all the way from a 5 years journey now. So that's all of my background here.
Oh, okay, that sounds good. I think I probably so interesting. So I think probably you could be able to share your some of thoughts as well when you are having the session. So anyone else have any experience on quality assurance? So okay. Okay, no, okay. So let's before moving to that, but what I'm trying to say is actually this software development industry is someone very this is one of the latest industry in this world. So if you looked at rest of all industries, like engineering, when it comes to engineering, there are many other fields. So civil engineering, mechanical engineering, many other engineering fields. And when it comes to the healthcare, or when it comes to the agriculture, all those industries, I think those industries has been running from the day one. The human being has been, I think maybe, or it may be origin of the humans, right? It might be starting from that that time onwards, right? So because of that, those maybe thousands of years. So because of that, the industries has been grown, and they are very matured. So even when you looked at maybe construction or agriculture or in any field, so all the industries are very matured, and it has been developed maybe many years. And because of that, those industries, they have, most of the time, they have very defined so when you looked at theories or whatever, even the practical stuff, we do have a lot of defined stuff. So even looked at the agriculture, we know all these concepts, and now we can accurately tell how much of if we are going to grow the paddy, how much of harvest you will be get based on the arc, or anything. You could will accurately tell those information, and based on the other considering other criteria as well. But when it comes to the software development, it's very hard. So I think because we have a it's less than 100 years. So I think the software development industry started in last more. I don't think it has more than 100 years of experience in this for this world. So because of that, so most of the stuff, sometimes even the definitions or everything, it's look like evolving. The what we have believed today, sometimes it's not going to be true tomorrow, and it will be evolved to another level. So when it other thing is, when it comes to software testing, I don't think software testing has more than 30 to 20 years of experience in this world. Even when it comes to Sri Lanka, I think it's maybe almost 20-25 years experience, and it won't have more than that. But even when you look at the entire world, I don't think there's something concept called software testing, software quality assurance, or quality control. So kind of a concept has been there more than probably maybe more than 30 years. It won't be more than that. So because of that, most of the concepts, most of the theories sometimes are really evolving, and what we are believing today is getting changed. So I think that the quality assurance is one of area that has been impacted hugely, and it's look like changing daily. So what even I'm looked at my career. So when I'm joining the quality assurance field in 18 years ago, so what we have believed has been changed a lot. So even maybe last 10 years, it has been changed to a different level, and now it's completely different. What it look like completely. So probably let me give those examples when I'm having the discussion as well. So it has been evolving. Because of that, we are not seeing any defined definitions. Even software, even when you looked at software, what testing or quality assurance, for that we don't have a concrete defined answer. So I just take you through a few examples. I just get my extract from some sources. So these are few examples about the definitions, how they have defined. So but one good definition what I found is, so the software, they have explained it as software testing is kind of exploring a software. So it's kind of exploring a software. It's kind of a technical investigation of the software to identify all the quality aspect of the product, and provide the complete overview of the product to the all the stakeholders. It's kind of doing a technical evaluation of a software and finding out all the information about it, all the information about the software and share it with all the stakeholders. So that's kind of, I think that's mostly kind of aligned to what we are doing in the real world right now. So actually, the even software testers or quality assurance engineers, usually what they are doing in their projects are they kind of exploring the software application based on the requirements or based on the information that they have, and they explore it and they find it out the quality of the product and all this quality information they will be sharing with the development, project management, and all other stake and clients and all these stakeholders. I think that's one of good definition I found it, but still there are many definitions, and we can't say which one is correct because it's still those are evolving. Okay, so so before moving to the next topic, so I just want to give a very good example. So why software testing is really required to this work. So if you so one good example is actually even the exact pro we mainly working on the finance infrastructure. So actually we are testing most of the capital market systems or applications available in this world. So if you look at the capital market, so the stock exchanges are the key venues that today's world economy even control. So even if you Google it, so even now you Google it, you could be able to find out what are the world largest 10 stock exchanges. If you Google it, probably you will get it. New York Stock Exchange as the world largest exchange. So actually they do more than million of transactions in a second. So sorry, in a minute. So and next the largest stock exchange is the Nasdaq, is again in US. So third one right now is Tokyo Exchange, and fourth one I think is Shanghai, and fifth one, if I'm not mistaken, I guess is Singapore, and then the London Stock Exchange. So those are the largest stock exchanges. Actually, we actually testing all these exchanges. So most of the projects even running in Sri Lanka now. So, but all these exchanges are mission critical stuff. So if we have done something wrong with this testing, so I think it will be ended up with collapsing entire world economy even. So we know how difficult we are because our economy has been failed right in Sri Lanka, right? So think about, so if we have, when we are doing a testing, when we are testing New York Stock Exchange, so think we could not able to test because some of the areas, because we are lagging of some of the information, or we might not clearly understand some of the requirements, or because due to some reason, or our testing designs, or some of the concepts we have used for the defining test strategy, or maybe poorness of our test strategy or something like that. If we have missed small areas of the application, so and we release it at green product because we never thought of the missed areas, because we will not do that mistakes obviously, right? We probably even we will not get that identify that. So think if we have released the software to the clients on New York Stock Exchange and they go live with this product, and when in the live production, so one of the area we could not able to properly test, think unfortunately there's a critical bug. So if that bug appeared in real application, what will happen? Can you imagine what will happen? Anybody can tell what will happen to the? So I think we miss one of bug because one of our poor testing concepts what we have used, and it went to the production. Nobody don't know that this product has not properly tested. So the issue has been appeared in live environment, and because of that thing, New York Stock Exchange, they have to shut down the exchange for a few hours to recover fix the bug, or to go back to the previous version of software or something like that. What will happen? So if they have to shut down New Stock Exchange for 3 hours, maybe 2 hours or 3 hours. Okay, so basically, so those kind of systems actually, if we have to, because if they have to shut down, those actually world maybe Fortune 500 companies may be trading in these stock exchanges. So right, probably they will not ready to tolerate with that, right? They don't want to tolerate their business for even single second. So probably they might immediately move out from the New York and they might start their businesses with other exchanges. So they might move to the Nasdaq, they might move to the London, they might move to the Tokyo or the Shanghai, wherever the other places available. So so because of software bug, the New York Stock Exchange has to shut down, and then all these businesses has moved. The millions of transactions happen in minutes. Now supposed to move to other exchanges. What will happen? Will this software will be able to cater? Probably not, right? Because those software might not ready to absorb this more than another 1 million of transaction addition to what they're handling today for a minute. Probably they won't be able to, right? Probably these changes also might get crashed or might get shut down or might get collapsed. The softwares might get collapsed, right? So if such a situation, probably what will happen is, so it look like a switching off in our house or our one of building one by one. So we will get dark maybe within few minutes of probably within few minutes, because all the exchanges will get shut down, right? So what will happen there? So if these all exchanges going to shut down, so these exchanges are the places where world economic control, even if you are going to buy fuel, so the crude oil, so those crude oil will be exchanged in one of exchanges. So even if you want to buy gold or anything, so gold will sold it at a gold exchange. So even if you want to buy flour or if you want to buy dal from India, even so India sell this dal and all the grains in their commodity exchanges. So even who are the people who bring to the Sri Lanka, they businessmen will go there to the India and they will purchase these items from the exchanges. So they will then after that they will bring it back to Sri Lanka. So if these exchanges are getting shut down, so world economy will get stopped immediately. I think probably world might get collapsed, and even we will not get flour or dal or anything, right? Or even we know without having this kind of problem how difficult we are struggling today, right? So if really these changes have to shut down because of the software issues, so the world probably will get collapsed. So I'm not sure even the satellites running on top of the sky will run after or not. Probably they will get collapsed to the ground. So entire world probably will get collapsed, and everybody will be dark, and everybody will start losing their life. So I'm pretty sure by end of that day, world get completely destroyed. I don't think anybody will live hereafter. So why these kind of things might happen? So the reason is we miss some bugs, right? We miss testing of some of the areas. So that's the software quality assurance comes in phase, right? So software quality assurance is a completely mission critical thing. So if we have missed a bug, you can simply kill this world as well. Right? So normally the software quality assurance industry is like that today. So we actually testing this kind of those are actually mission critical systems, extremely mission critical. So the where world economy even control. So even looked at even that's why software quality, the previously we called different names, but then now software quality assurance has become a science. So because of this criticality, quality assurance has become currently science. Same time, it has been become an engineering process as well. So that's why we call now it's software engineering. So initially just only software testing, and it has been moved to software quality assurance, and now it become a kind of engineering. So it's a quality engineering. So why this become a quality engineering is because what we have to test is completely mission critical system. If you have done any mistake, so it probably we are ruining the entire world. Probably we will ruin our entire lives as well. So to do that, to avoid that, we need to have science. So without having science, we won't be able to do that. That's why quality assurance has become a science, and a lot of theories, a lot of concepts, a lot of techniques has been introduced. And same time, it has become a now engineering process. So so that's fine. We are having new concepts and techniques, but still we need to have engineering process to implement it in real world to and make that product quality software out to the client. Right? So that's why we in this world right now, quality assurance software testing moved to quality assurance. I think last 20 years time. Then now it has been become to engineering. So it not just validate whether button click is working or not. That's not a quality assurance. So that's not the software testing what we have in front of us. It's completely complex and testing these complex systems, again, we need a lot of complex rules, concepts, and techniques will come into picture. Okay, that's why I just want to give example. So how mission critical software testing is, how important, and what will happen if you miss any of these if you have missed any of these functionalities when we are testing in real world. So these are few examples what actually world face in last period. So this one example is Arena 5. So the rocket has completely destroyed, and in 1996 that's because of software error. So the loss world face is 500 million. So other one is that is happening in 1984, very old time. So that's a radiotherapy machine. It caused a problem because of the software failure, because of software error. So, and 6 patients has been died, 3 people has been died, and it completely lost for the world. So other one is the one of latest one, Knight Capital Group's failure. So actually they are kind of a trading entity. So there was a software error in their system, and that appeared in real time. And they because of this failure, so there are 148 companies has impacted, and the loss is 440 million. So other one is video assistance system that they decided to use in Netherlands, one of world football championship. So actually this system has error. Some of the defects has appeared when they are running in the real world championship tournament. So because of that, entire tournament has got failed. A lot of chaos has happened. So even we know. So if you not be able to have whatever the software what we have, even in the cricket matches, right? So if we have given the incorrect predictions, what will happen, right? Even the people who are watching matches, so they might start destroying the grounds and everything, right? So that's probably will happen. So if software error is happen, so and the incorrect decision has been given, so it ended up with a complete mess. So that's exactly happened in this Netherlands in 2010. So that's all this because of the software testing errors. So the next the question is, so I think that's a good one. I'm just going to discuss with you all. So anyone know similar global software failures that anyone experienced it or anyone heard about? Any software failures that is happening globally? Can anyone tell, or even you can chat and share your thoughts? Something that you have noticed that globally we have impacted any software failure? Okay. So anyone heard about the Millennium Bug? That that something happened sometimes ago. Actually, it's not very recent one. That's one of major software failure. Do you know about the Millennium Bug? Okay, so Millennium Bug is something that's supposed to appear in year 2000 when world is moving to the new millennium. So at the year 2000, this bug expected to be appear. So bug is, so when we are developing our softwares before year 2000, when we developing our software, we use whatever the programs we have used. So we use date as a 8-digit character. So we define date as a 8-digit character. So so how we write it is initially either date, month or date, so 2 digits, and then hyphen or dash for another digit, so 3 digits. So then month, then another 2 digits 5, and hyphen or dash another digit 6, and year as a 2-digit character, so 8 digits. So that's how the year has been formatted. So every programming language, that's how they used it. But when we comes to near to year 2000, somewhere 98, 97, 99, so people start realizing it. So by year 2000, by January 1st, so this year is moving to the 00, right? All the systems it's supposed to move to the 00 automatically. So think one of you had a fixed deposit in one of bank, so that you have deposit and in 1999. So what will happen by year two? What's supposed to be happen by year 2000? So the bank will automatically calculate their interest by deducting days, right? So if the bank systems automatically upgrade to 00 as a year, so how they will be calculated? By January 1st, automatically they will deduct the previous, they will deduct the year from the current year to the previous year. So they will be deducting 00 to 99. So they will get a minus 99. So what will happen in formula? So your interest will be automatically the negative value. So by January 1st, you're supposed to get a less amount than you already deposit. So that's ideally supposed to happen. So everywhere that's supposed to be happen. So because of that, world expect even the satellites who are running supposed to get collapsed to the ground. So what will happen? So if they're supposed to collapse to the ground, give me a minute. I have a small echo. Sorry about it. There's a small disturbance in my side. Okay. So so then what's supposed to happen is, so because of this error, so everywhere everybody expected failure. So and world expect even the satellites supposed to run in above our sky supposed to get collapsed to the ground. So because of that, they have to do a small change in every software. They have to change the date format is as a 10-digit character, because they have to increase the last year as not to the two digits. They have to increase for the 4 digits. So because they have to increase it 4 digits, each and every software developed and each programming language and everything, every database and everywhere, they have to do this change. So luckily, we're able to do that. But the cost they have to pay, the entire world has to pay, even right now could not able to calculate it. So luckily everybody survived, and no, we didn't have any issue. But we expect if we are not going to do that, we are going to collapse this world as well. So there's another very recent, I think that's the one of very recent example we have right now, similar to that. So scientists has been figuring it out now very recently. So usually we know we have a 24 hours in our calendar for a day. So to rotate this world to a one cycle itself, it takes 24 hours. That's a very common thing we all know, right? But the scientists right now, they now have been identified because of various constraints happen. Now the not 24 hours is not the actual value. So right, actually now there's a 1 second leap. So actually, it's not a 24 hours. There's a one addition. Actually, we need to deduct a 1 second from the 24 hours. That's the actual value. So they have been identified recently. I think this got disconnected.
Now we can hear you.
Okay, I think it's disconnected. Yeah, I have the rights again. Give me a second. Okay. So the reason is, so if software testers has not been think about this, if what will happen, a additional second has to be added to the time, or 1 second has to be dropped from the clock. So how our systems will be work if we have never think through those things. So if we have not tested our systems for such a scenario, so it will be a bug in future, definitely. So that's why the testing is not easy again. So if we are doing the software testing, we should have been think through all these conditions when we are deriving our strategy, or our testing strategy in our project. So we should have think through all these conditions. So challenge is how we are going to think those things. So that's really complex. So if we have, so in real world, so we have to think all this. So another example is, so usually in so think we have a banking system that we have developed. So so if you so think if we are going to transfer 10,000 rupees from one account to other account, so how we are going to write it? Usually you will write it like 10, 000 and dot and 00. That's how we will be right. So so I think let me try to use a whiteboard or something to just show. Okay, I'm not seeing. Okay. So you will write like this. So that's how so in English, so we will write like this. So English, we will use the dot for the decimals and comma to separate as a separator. But this is in English. But if you have gone to the French, so different languages, it is different. So if you go to France, in French, they will write it as differently. So usually French, so they will use the comma for the decimal and dot for the separator. So they will write 10,000. So if you have gone to the France and if you are going to transfer money, you will write it like this. So what will happen if you are in now France and if you are going to transfer your money from your account, your internet banking account to another account, you will write like this. So how this application, if your application has not been properly decided, implemented to identify this, it will transfer 10 rupees probably, because right. So rather transferring 10,000. That's the one thing. So this is what we call localization. So in the different locales, right? Different localizations. So when it comes to France, or when you go to, if you go to Arab, when you go to the Japan, or when you go to China, so they will have their own localized the languages. They will use them, and they are having their different definitions, right? So if you are unable to your system unable to identify these, how they will do? So they will completely miss, right? They will transfer 10 rupees rather transferring 10,000. So how you should do avoid? So your application should be intelligent enough to identify which country you are in, which locale you are in right now. So and based on that, it should translate. Right? So those are fundamental testings we should do. So this we call localization testing. So let me later describe a little bit further on this testing type. But we usually call localization testing. So if you have a software you have developed, and if you haven't tested for the localization, you will end up like this kind of scenario. Similarly, the other portion of this is, so think if your account is in Sri Lanka and you are right now in the France and you are transferring money to a friend in US. So what will be the time zones? So the Sri Lanka, it's now 12:16, right? PM. So still this is the time. So The France probably another 5.5 or 5 hours, so probably we'll take it as not sure now, but we'll consider it's 7 or somewhere. The US, it will be now probably midnight, right? It will be 2 a.m. or maybe 2 a.m. So probably it's 2 a.m. right? So now you are right now in France, right? You are going to transfer 10,000 from France, right? 2 a.m., 7 a.m. So what will happen? Your account, your transaction has been updated in 7 a.m. at Sri Lankan time. So actually your account should be updated at 1.16 a.m., right? 1.7 p.m. But rather updating like that, if it is updated at 7 a.m., so you calculate the few additional hours, you will have impact. So your account in between these 5 hours, there's no 10,000 rupees, something has happened missing, right? So what will happen that your transaction, so ideally it's 2 a.m. and your friend should get, he should get at his 2 a.m. Rather he is getting 2 a.m. What will happen? It's updated in his account at US 7 a.m. So he has to wait another 5 hours to get the money, right? It's not online, right? We don't know where this money they are during that period, because none of system has been tracked it, and money has been lost for within a 5 hours period, right? So these are actually we call internationalization. So our software should work perfectly. So if we have done the transaction at 7 a.m., it should happen updated in at 1:16 p.m. at the Colombo, and say 2 a.m. at US as well. So it should be like that. So if rather updating it like this, if it is updated in the different time zones, it could not able to figure it out which time zone I am in and my account is there, and which time zone my database, the database will be available in some other country. It may be located in Singapore, in one of cloud, located in cloud solution has been set up in Singapore, right? So if it is updated in Singapore time, that it will completely miss, right? So it should not be like that. So it should be correctly reflect the correct exact time. So how these we call internationalization, and internationalization testing is one of mission critical testing we should do. If you haven't done this, so it will be a complete failure there. So those are the few steps I think. So I should tell about. That's why we need this software testing has become we need a lot of science, a lot of techniques, a lot of engineering process, right? Okay, so other question I should ask from you is, anyone heard about any software failure happen in Sri Lanka? So all these above examples are related to the global, right? So what I have mentioned is any similar examples for the Sri Lanka? Anybody aware about those? I'm pretty sure we might have many examples. Okay, so let me take a very old example, right? So it happened some very old time, sometimes ago. I'm pretty sure you all have the ATM cards, right? The ATMs are right now very common. It's a very common old technology. Right? It's not new technology even. So we all have ATM cards, and we usually use the ATM cards to get the money. Or even right now, for the deposit the money, we use the ATMs, right? So can anyone tell me what is the flow you can see in a generic ATM machine? What if you want to get 1,000 rupees now from your account from one of ATM? So what's the process you will follow? What do you need to do first? What you should have done first?
We have to enter the card and type the PIN.
Okay, excellent. Right. So you have to enter the card. That's the very first one. So we'll insert the card. Okay. What is the next step? So PIN. Okay. Sorry. So what's the third step? So we will take it a very simple example. So probably then they will ask whether what's you want to do. Basically, they will ask the language and all this, but let's omit them. So additional steps. What will the next major step? They will ask what you have to do, right? So you have to tell withdraw. So you have to tell withdraw. So what will be the fourth one? So once you
They ask
mention,
for changes sometimes.
yeah, so changes and
documents?
yeah. So and then probably they will tell the amount, right? So basically, you probably I'm simplifying the flow, but
Yeah.
yes, there are a lot, but and then finally we'll tell the amount. So what will happen? So once what will do the machine? So once you once you send the amount and they will ask the confirmation probably, and after that, what will do the machine?
It is checking the available balance and given amount.
Yes,
Whether
exactly.
it's-
So finally, the machine will release the amount, right? Machine release the cash. So after that,
They are asking whether we want another task to be done with the system.
Good,
Otherwise,
yes,
we
yes.
can exit.
Yes, exactly. The final outcome is the machine will release the card, right? So you will get the card back from ATM, right? So that's the last option. So basically, these are the very straightforward steps, right? So in ATM, so this is the flow actually we usually facing every day, right? So we you in Sri Lanka, this ATMs has actually, if I'm not mistaken, I guess it has been set it up somewhere in end of 80s or the early 90s, right? So 89, 90, 91, those are the period they actually commercially they are start setting up the ATM, right? Most of the banks like Sampan, HNB, and same time BOC, even government banks, they started setting up the ATM. And how they promote these ATMs is so we usually people has to go to the bank and get the money in the daytime if you want to get the money out from the bank. So because of that, so that's the hassle they are going to minimize with this ATM. So immediate those days. So because of that, they promoted it as right now because of this ATMs we have in everywhere. You don't need to come to the bank, even you are in a rush or in a midnight. You can go to the bank, go to the ATM, and you can get the money out, whatever the money you want out, you can get it. So that's how they promote, and that's the mentality even had with ourselves. So what happened was, and other problem that happened those days is the ATMs are not like current ATMs. Those are very primitive ATMs we had. So those ATMs have a less intelligent, like not latest ones. So because of that, they are unable to handle multiple cards. They were able to handle one card at one time, and the very primitive ATMs. So I think almost 30 years back, right? So what happened was once they promote this process to people and to use the TV channels or whatever the advertisement. So now you don't need to worry, even midnight, even rush, you can go to the ATM quickly and get your money out. So people start using the ATM. What happened was, so people use this flow, right? So insert the card, enter the PIN, mention the activity, then mention the amount. So as soon as they mention about the bank release the cash. So what happened was, as soon as cash released to the individual perspective, even my perspective, my workflow is completed, right? Why I go in front into a ATM is to get the money. So once I got the money, my objective is achieved, right? So people, what happened in everywhere in Sri Lanka is, as soon as we get the money, people get the cash into our pocket, and we vanish. What we forget is, we forget to get the card back from ATM. That happened everywhere. Right? So what happened was, because these ATMs are very primitive, they could not able to handle multiple cards, so they could be able to handle this kind of situation. They never expected to have this kind of situation. People go mostly off banking hours, even night, go to the ATM, put them ATM, and most of the time they get the money. As soon as they get the money, ATM takes some time to release the card. before they releasing the card, we forget to get the card and we moved out. So we managed, right? So after that, what is happening is the ATM gets stuck because the person has not get card out. Now a card is inside the machine, and after that, the ATM gets stuck. So every day in night, every ATM start getting stuck in Sri Lanka. Why? Because people are forgetting this cards getting back, right? So this is the flow. This is the flow they have been developed in their system. And this implemented in Sri Lanka. This is how they are implemented in other countries as well. But it didn't work for Sri Lanka. So everywhere, every bank, next day morning, they have to clean these ATMs and reset the ATMs and they have to do a lot of manual effort. Until that, none of people able to use it because ATM is stuck. So how did they resolve it? How did they resolve it? So what actually they did is they interchange this step. This is how they resolved it. So they release the ATM card first, then they release the cash. So if you have looked, some of the banks still use this updated flow. Still they haven't reverted back to the original flow because still they are not sure about that. Even the ATMs are right now intelligent enough to handle this kind of situation. They are still using the old flow. They have updated flow. So this is how they have fixed it. They change the flow. This is actually a bug. This is software bug. So what's the bug here is this software has not tested for the Sri Lankan culture. Right? So you just implement a software everywhere without thinking our culture, our behavior pattern, and it went completely mess. So that's a one of very good example we have in Sri Lanka. It's a complete mess because they have to put a huge loss to correct these systems, and everywhere people's frustration because ATM can't use it. Whenever you go into ATM, it shows it's not working, right? So people are in a rush and hurry. They thought they can get the money in the night, but it didn't work. So it become a huge mess, and people not worry about the banks. They are complaining to the banks, and bank losing their customer satisfaction, huge loss, right? So that happened because the software these banks has developed, and they have not tested for the Sri Lankan culture. So that's the other point, right? So we have to test whatever the software you are going to deploy. You have to test based on this cultural aspects as well. If we are not doing that, it will ended up with like this example. So that's why again. So testing is not something very simple thing, or it's just button clicking on something like that. It's completely a science, right? If we are not using correct concept to test this application, somewhere someone has to pay for it, right? So that's one very good example happen in Sri Lanka. If you know any other example, you can tell it. So there are many. So I think I actually get one nice example, but there are many examples similar that. So because of the software failure, people has to pay a lot in Sri Lanka. So if you have done this software testing at correct level, so these kind of failures will never happen. Okay. So let's move to the next step slide. Any questions or anything that you want to ask? Anything you want to challenge? Okay. So let's move in the next slide. So basically, I just want to take you through some of the software development models. I think I will let you know why I have done at the end. So once I have done, so there's a specific reason on that again on the quality assurance perspective. So we usually in this world we have two different types of software development life cycle. One is a sequential, and other one's incremental. Sequential is we do all the activities in sequential manner. We will do one activity first, and we will move to second activity. Incremental is we will have a small portion of software will do the development, and test, build it and test it and release to the customer. So we will have a small portion of software and continuously we will continue as incremental development. So, okay. So what is the most old sequential software development model that we all know? I think that's everywhere. Most of the time we know this. We learn this and we use it even most of the time. What is the
waterfall model, right?
yes,
Waterfall model.
exactly, correct, good. So waterfall model is the world oldest one. So the main problem, and even sometimes we still use, but I think very rarely now people are using the waterfall. The main problem is in this model is, so we have different phases. So initially we have the requirement, then analysis, then design, then coding, then testing, and then deployment and maintenance, etc. Right? So we have different phases. Each phases, they are very clearly defined R&R. So the requirement. So in requirement phase, the requirement gathering will done, and mostly the business analyst and or similar kind of roles there will be, and they do the requirement analysis, and then analysis and designs comes, right? So and then phases from the analysis, maybe business analysis and architects get together and we'll do that. When it comes to design, so software architects and software tech leads and engineers, they will do that. And when it comes to coding, software developers or these engineers will do the coding. So when it comes to software testing, so quality assurance professionals will come and they will do the software testing, and then it will be released. The release engineers will be working on the deployment end, right? So that's how it happened. So major challenge was that if once one phase has been completed, it will move the next phase. So when quality assurance perspective challenge was, so once you've done the testing, once you complete the testing phase, you only get to know all the defects of the application. So sometimes those defects has to be fixed at the requirement level or analysis level, design level. If the defect is the requirement level, again we have to do the analysis, we have to do the design, if there might have design changes, and after that we have to do the coding changes based on that, then we will go to the testing. And huge cost. So the cost is extremely high because the testing comes at the very end, and we have to go from the beginning to look at what are these defects they are going to report, and we have to do a lot of rework. So cost, that's a major drawback of this model. So to overcome this drawback, so the industry has figured it out that another model that we call V model. Sometimes some people will call double V model as well, or W model. So it's almost same. So what they have introduced is, every phase they have introduced a testing or quality assurance phase. So business requirement phase, they have introduced a acceptance testing phase to validate the requirement. The system requirement phase, they have introduced a system testing phase. The design phase, it's kind of integration. The coding phase, it's a component testing and unit testing. So each phase, the quality assurance phase also has been introduced. So because that's how they make sure the testing will be done at each phase, not that end of the entire software development. So that's how they have been resolve this problem. So what is the highest challenge, highest cost or highest effort they have to put previous level? So but still there's a problem. So the testing will come at the end of each level. So, and there are a lot of testings has to be do and each testing phases, and still there are a lot of drawbacks with this. So because of the lot of testing has to be, even the quality assurance, lot of quality assurance activities. Each phase there are quality assurance involvement and a lot of effort because of that. So that was the major challenge. So to overcome this challenge, actually the iterative model has been introduced. Right? In iterative models, what we usually do is we will divide that requirement into a small portion, and we will develop it as a small requirement, and then we will do the designing and we'll code it and test it and release to the client or whoever is stakeholders. Then next requirement we will take and we will develop on top of that. So what will happen was, so in this the quality has been really increased because a small person always delivered, and a lot of development work has reworked on the development and requirement side, it has reduced. But alternatively, because we are releasing small portion, so when we are releasing first release, you have very less testing effort. But when you are releasing second release, you have to retest what you have done in the first release as well, whether it's as a broke or not. So when it comes third release, you will have to test second and third release again. You have to do a lot of regression. When it comes to 10, 20, or 30th releases, you have a lot of huge regression test suits. You have to use it because you don't know whether initial work has broken or not. You have to certify it, right? Because of that, regression effort has increased again with the iterative. But relatively, this is one of good model. So people start still using the iterative models, a lot of development teams. But in the latest, with this all goods and bads and all considering everything, so what latest is right now in the agile. So agile, basically in agile, so what we have is kind of a collaborative understanding of this all different kind of roles. So previous models, we have dedicated roles. So business analysts, we have business analysts, and they have a dedicated phase to do that. This, architects and tech leads, they have dedicated area to attend on. Designers and developers, they have dedicated phase. The quality assurance engineers, they have dedicated phase. With introductions of agile, so this concept a little bit diluted now. So it's kind of a collaborative. Still, we have this role, but it's collaborative understanding or collaborative responsibility. So we all have collaboratively equally responsible to make sure correctly gather the requirement and transit to correctly to a code and correct test cases. So that is equal responsibility has been introduced, and people has to work together equally. So other thing is, so before come to agile, so we have multiple roles. So when it comes to the business analysts and these people as one set of people, when it comes to development, so we have lot of different development roles as well, like UI engineers, UX engineers, backend engineers, middleware engineers, database engineers, so multiple roles. When it comes to testing, again, manual engineer testers, manual quality assurance engineers, performance test engineers, security test engineers, right? Automation engineers, right? The multiple roles. So that's how it has been derived previously and has been executed. But with this agile, those roles start diluting. And everybody has the collaborative, because everybody has the collaborative understanding, collaborative responsibility to make sure that project delivery has been done without having any issue. And other concept what we are using here is, so with this agile, we expect to move as much as possible to the left side. So previously, so if I take it, so previously software development, so initially this is requirement, so then design we will be like this, then coding like this, then testing will start like this, right? It will, but with agile, so we move all the these phases has been moved to the left. So it is becoming, we are moving left. So the objective is push all these phases as much as possible to the left. So because that's the world trend even, right? If you look at the world in any technology or any social economic concepts, everything, everywhere, trend is to move as much as possible to the left. That's the objective of everywhere. So the same concept has been used in agile. So everybody, the agile concept actually push us to move our regular testing, so regular software development phases as much as possible to the left. So because of that, what happened is, so requirement and development testing all come to if we can bring it to the zero, that's good, but I don't think we can bring it to zero, but move as much as possible. To do that, how we could do that? So do that, requirement understanding has to become a collaborative. So developers, engineers, so quality assurance engineers, and business analysts have to work together. And once business analyst has done the requirement gathering part, that the first thing we have to in agile, what we are expecting is to testers, we will, I think in the our second session, I'm going to very deep dive on this because there are a lot of new techniques on it. So what testers has to do is, testers has to write their test cases immediately. So as soon as requirement is ready, testers has to think requirement 1 is ready. So before even developers start coding, test case has to be right. If you have requirement 2, you have to write test case. So you have to develop. So once you have done the test cases, I think there's, so the next immediate step is agile. So there, I think there's no concept even called manual testing right now, right? So it has been almost died. So what we have to do is, once soon as we have done the test case, we have to automate it, right? You have to automate it. The first test case. The second test case, you have, once soon as done, you have to automate it. So what will happen? So if there are 10 requirements like this, we think we have 10 requirements like this. So I think you have written 10 test cases and you automated 10 test cases, right? So this will done as soon as you have done the requirement. So your test case will be done as soon as your requirement is done. So but code is not ready. So developer will start doing the coding. The first day, the developer will done the, so the very first day, there's no code, but you have 10 test cases. What is your result? So no code, but we have 10 test cases. So once you execute these 10 test cases, the quality engineer executed 10 test cases, what he saw her result? All fail, right? Because no code, nothing, right? Everything will fail. The day 1, so probably day 1, 100% fail. Right? So what is the day 2? So think developer has done one requirement implemented. So then my first test case will get passed because the first requirement has been done. My test case will get passed. So the second day, I will have a 90% of pass rate. Sorry, 10% of, or 90% of failure rate, whatever, no worry, whatever the basis. So day 2, if developer has done the requirement 2, so day 3, right? So it's day 3, developer has done the requirement 3, so requirement 2. So my second test case will start passing, but still rest of test cases will get failed because there are no codes for other respective test cases, right? So 80% failure rate, right? So day 11, what will happen? So all the requirement has been implemented by developer. So I already have the test cases, it will be automatically executed. Ideally, by end of the day, everything should get passed, right? 0 fail. So this is how it's supposed to be happening in agile. So you will done your test cases at the very beginning, and whenever the developer is starting coding, it will get automatically passed. When developer is completing your code, your test will be completed. Your quality assurance has been completed, right? Your process has been completed. So ideally, this is the expectation of the agile. So when you are completing your testing, so when you are completing your development, the testing also will get completed. There's no different testing phase. It is it is incorporated into the development cycle itself. There's no separate testing cycle, right? So that's ideally should be happening in agile. So with agile, so the entire phase has been, all the phases has moved as much as possible to the left. So we call shift left. So that's the concept we are calling. In agile, we expect to shift left. So shift left is the even world trend, not in the technology everywhere. Social economy, even it comes to other technologies everywhere. So shift left is the techniques that we are believing right now. Maybe in 5 years time it might be not there, but that's the technique that we are thinking, right? So this is agile, right? Basically, if you fundamentally describe it, right? This is outcome expected by agile. So do that. So to do that, we initially as I mentioned, we had multiple roles, multiple developers, be UI developers, backend developers, middleware developers, DB engineers, when it comes to manual testers, automation testers, performance testers, etc. Right? Multiple roles. But with this concept, these multiple roles right now has been diluted. The now industry trend is we will have only 2 roles. That's the industry trend. The 2 roles are, you might know already sometimes. So one key 2 roles is full stack developer. Rather having separated development tracks, we expect now to be people to be a full stack developer. They are the people who are getting higher paid even in industry now. Right? If you can do the UI, UX to the backend and DB level, so you have become a full stack engineer, and you are the most appropriate person to run this agile projects, right? So that you have become a full stack engineers become the highest paid people even, right? So similarly the quality assurance, so manual testing everything has been right now dying. Now the industries we call SDETs. What is SDETs? SDETs means software development engineer in testing. So QA has moved right to the SDETs. So SDETs who are the people who can write derive the test case with a lot of scientific concepts, design the test case and automate it and do the non-functional testing and execute. Everything should be able to do that by this. Everything should know, and SDET should know, integrate this code, the automation code to the DevOps pipeline. With your CI, so they should be able to integrate CI/CD pipeline for the day one. That's how you will get this 100% failure at the beginning. So if you have automated and you already integrated to your DevOps pipeline or the CI/CD pipeline, by day one, developer is coding and committing the code, he will get the results. 100% failed, 90% failed, 80% failed, and finally it's 0% failed. That's obviously where your product can be delivered. So that's the expectation. So this should have these all qualities, all competencies, skill sets. So those are the 2 roles right now we have. So in the development we have a full stack developer. Similarly, in quality assurance, we expected to have SDET or software development engineers in testing. So that's the current QA trend, the quality assurance expectation in this world. So it might get changed next 5 years time, I don't know, but that's the current highest valuable roles and highest paid 2 roles as well. So that's why I just want to introduce this, discuss this again, this software development life cycles, because all these roles and all these concepts are aligned to what we are discussing, are aligned to this new trend. Right? So this is where what we are right now in. Any questions? So if you're not agreeing, so you can argue it, no worry. So anything you want to?
Just to clarify one thing, is
Yeah.
it the regression time is reduced by automation, right?
Yes, obviously.
Agile development?
Yes, obviously, because we will be automating everything, right? So our all the test cases are automated. So that's the actually end objective, right? Probably we might not be able to do it real time, but because we are automating everything, so test cases will be automatically. So we no need to manual execution time. We should not have manual execution time in daytime. So one good example. So I think I just would tell you. So because I had a very recent experience to work with the Google. Right? So the Google platform, so they automated complete testing process. So even sooner the requirement has done, so requirement not that coming with as a regular format, so probably it's kind of a something like feature file format, but as soon as they have done the requirement, the test case will be auto-generated. So only the small manual interactions are there to tweak the test cases, and test cases will be automatically automated itself. They have their set of framework that test case, there are manual interactions, but a lot of scripts or test cases will be automatically generated. Then only whenever the failures are, only the manual interaction happen. So then those test cases automatically built into the DevOps pipeline, executed it, and the results automatically pushed back to the requirement management platform. So again, the results against the requirements again. So the requirement is red or green or amber. It's automatic. Every day they will get, people will code it and commit it. This report will be generating automatically every day. So I think they have done it very nicely. I think that's probably how they are. That's why they have this kind of very probably strong set of platform, right? So so I think that's how they are doing it. So I think that's how they have been. I think that's the end expectation at the Agile as well. So we should have properly automated and integrated with the DevOps pipeline. So it should, the regression time will be very minimum. Even Google defect automatically get raised. So they will analyze the logs. So again, to do that, the developer has to implement their logs to automatically analyze. So their tools automatically analyzing, and their errors, they will be captured separately, and they will raise the defects automatically. So I think that's the level. I think with that level, I think everything will come to shift, right? So ideally, just to developer just to have to code automatic. So the quality assurance role has been moved to implementing this entire automation. It's kind of a complete automation. So that's the objective of the quality assurance people as well. So their expectation is to develop this entire automation and run it and implement it. So with that, I think regression effort will minimize immensely. Did I answer your question?
Yes, I got the clarification.
Yeah.
I think as I heard from you, only the quality requirements are focused on developer or the DevOps engineer. Other than that, all the things are automated, right?
Ideally, so that's the ideal situation. I think the best place I have noticed is Google. I'm pretty sure probably other IBM or Microsoft too may have done this. So, but
are they doing quality? I mean, not the non-functional requirement also tested?
Yeah,
Through automation process?
Not 100%. That's one of toughest thing. So it's not 100%, but some of the non-functionals also, they have think in some extent, because non-functional testing sometimes when it comes to performance and all these, those are we should do it very different set of we should have the maybe equivalent to production equivalencies and environments and those things. But some of the non-functional aspects, actually it's like cross-browser testing and all these device compatibility and all these kind of stuff. I think they have bring it to in part of functional and they automate it. But I agree that some of the security, performance and those, there are set of testing they are doing it separately. I think those are the areas even to do the researchers and bring them to a kind of a level of automation as well. So, but I haven't seen much in that, but it's still even all these non-functional, again, you have to develop the framework tools and do that. So but mainly what we are not seeing is monitoring and controlling and monitoring. That portion has actually still doing it manually. Okay, let's move to the next episode. Okay, I think that now the one other interesting thing I would like to discuss. Okay, so before that, let me have a very quick think upon that. I'm pretty sure you all aware these testing types, but basically in the testing types perspective, so we have two different type of testing. So one is called is functional, and other one is non-functional. That's what we exactly discussed now. So what is exactly functional? In functional testing, what we are going to answer the question what. So in functional, if you can, that's the question we are asking. So what type of functionality is available? What type of requirement has been implemented? What will happen if you are going to do this and that? And so that what question is what we are going to trying to answer in the part of functional testing. So in the non-functional, what we are going to always ask is how. The question is how. So how well this application will work for the 1,000 users? How well this application work for multiple browsers? How well this application will work for the multiple devices? Or how well this application will work for the large volume of database. So that question what we are going to ask, well, so these are the two different testing types we have. In addition to that, there are another type. It's again part of functional and non-functional as well. So let me explain it a little later. So when it goes to functional, so basically unit testing, integration, smoke, use exceptions, localization, globalization, or internationalization, what I previously mentioned, all this comes under the functional. So we are going to answer the what question: the performance, endurance, load, volume, security, cross-browser, device compatibility, all this comes as a non-functional. So where are we going to answer the how well this application will work? So those are the two different type of testing types what we have, right? So in mainly, right? So and there is another testing type we call change related. So I think, so let me quickly brief it as well. So change related testing is, I think that's nothing new. So in addition to when you are building application from the scratch, sometimes we might have to implement new set of requirements for existing application, or sometimes we might have to do a set of defect fixes for existing application. So change rate and testing, we have two different type of testing. One is for the confirmation, or other one is the regression. The confirmation testing is, so think you have an application and you had a set of bugs running last few years and you decided to fix it and release a new release. So you just fixing a set of bugs and you are releasing it. So then what we are doing, we call confirmation testing. It's kind of a retest. We will retest for the area that you have been fixed, or defect fix has been done. So regression, so other stuff is, so think you are in your application, you're releasing a new feature. So you have 3 features and you're adding another 4th feature. So then rather testing only the 4th feature, you might have to test what are the all other impacted areas for other 1st, 2nd, 3rd features. So finding the impacted features and finding your impacted test case and running it. So we actually call regression. So this is other testing type. So confirmation or regression testing that comes under the change related testing, or we have functional or non-functional testing, or those are the 3 different types of testing. So the change related testing again be part of functional or non-functional. Okay, so those are the testing types we will have in the real world. So we'll come to a little bit on testing types and testing tools at the end. So before moving to that, so I'm not deep dive on the testing types. Okay, so I need to, these testing types I just brief because I need to map how these testing types will work in real world, right? So think you have given a project, you have been given an application to test. So you have been, you are the quality assurance engineer or the lead or manager in your one of your project, and you have been asked to make sure the quality of this application. So how we are going to do it? Then you have to plan it. So obviously, the first thing you need to plan. So in your plan, you have to build your quality assurance strategy. So how we are going to test? Strategy is something. What are the testing types I am going to focus? So very basically, testing strategy is the correct testing types what we are going to perform. So the quality assurance. So if think you have this, you have first thing you have been asked to test. You have make sure the quality of this application. Then you have to build up your quality assurance plan. So in the quality assurance plan, there are many aspects. So we will go through all the quality assurance aspects of this plan at the last session, but because this session I just take it to one portion. So that portion is we have a test strategy in our plan. Strategy is the heart. So basically in test strategy, what we are going to tell is what are the tests. Very simple. What are the testing types we are going to do for this project to make sure the quality. Okay, so right now, so I just explained few test cases, right? So here, under the functional, non-functional, there are these. If you go Google it, you will be able to find out thousands of testing types, right? So what are which testing types we are going to use your project? So how we are going to decide that? So you have multiple testing. You have to derive your test strategy. So qualification strategy. Then you have to figure it out the correct testing types for the strategy. So how we are going to do that? Either you will Google it and find out all the testing types and list it down. So if you can do that, that's great. Then you can make sure that you have done and tested for each and every testing type, right? But ideally it won't work, right? You will not have time, you will not have effort, you will not have a budget for that, right? So everything will be limited. So then how we are going to do that? Okay, that is the problem comes in, right? In real world, in industry, so we won't be able to do it all this testing. So now with the quality assurance manager or the lead or the person, responsible person has that challenge to figure out correct testing types for his quality assurance strategy. So that's one of key challenge. For that, we won't be able to do it just here and there. We might have to use some concepts, some theories for that. So there are few concepts are available in this strategy. So before I'm going to deep dive on this concept, so I just want to have a very quick brief one. Risk management. So anyone heard about the risk management? This is not something related to software engineering even. The risk management is something common. So what do you know about the risk management? Anyone heard about the risk management? So what is risk management? So okay, let me get a very recent example. So we know all we have some challenge because we in the Sri Lanka we don't have enough dollars, right? So because of that we don't have enough fuels and we have a limited quota of fuels to use, right? So so in somewhere in January, if we have noticed something similar, this somewhere in January if we have noticed, okay, we are losing our dollars, it's coming to end. Because of that, we won't be able to buy fuel by somewhere in April. If we have noticed something like that in January, we call it a risk. Unfortunately, I don't know whether we find it or not, we didn't care it, right? So if we call it a risk. So if what you need to do if such a risk is happen, identify. So think if you identify similar risks in your life, so something will happen in future. Risk is you are going to identify something that will happen in the future. So if you have identified that risk in January, if we have identified, so probably we are coming to end, we will not have much dollars and we will come into a level, we won't be able to import fuel. So if we have find it at a risk, then we have to define it as a risk. This is a risk, probably might happen in future, might happen in 3 months time. So the next step is, if you find out that this kind of risk, next step you have to do is, you have to find out the criticality of this risk. How critical? So if you have find out if you are losing dollars and if you don't have to, if you can't buy fuel by 3 months time, the criticality is extremely high, right? Because without having fuel, we can't do anything. So we can't have the vehicles, we can't bring the foods to the Colombo, nothing will happen, right? So complete mess. So it's extremely critical risk, right? So then in the risk, what we need to do is the third thing is, once we identify the criticality, we need to identify the probability of occurrence. What is the probability of this risk happen? Whether it will happen or whether it will not happen. So what kind of risk? So if you have figured out this risk in January, so there's the first probability that we need to figure it out criticality extremely high. The next thing is probability occurrence, whether it will occur. So if we have enough money coming from the tourists, so then probably it will not occur. If we have enough money coming from the people work from outside Sri Lanka, if they are ready to send, so probably this might not occur, right? So if we have enough loans coming in future, so this will not occur. So this is the probability of occurrence that we have to figure it out. So if we have ideally, if you have figured it out this whole risk, so probably it definitely it will happen, because we don't have enough money coming from tourists. We don't have enough money coming from employees who are outside the country. We are getting as a loans, nothing, right? So we don't have, obviously 3 months time, we will not have a simple dollar to purchase fuel. So then the probability occurrence is very high. So once we identify that, we can multiply criticality and probability occurrence and figure it out the risk exposure. We call it risk exposure. So the second thing we need to identify the risk exposure. So third thing is, what's the third thing? The first, identify the risk. Second is priority and criticality and exposure. So then third is, if you have figured out that risk, then if you feel that risk going to happen definitely within the 3 months or 4 months time, then you should build up your mitigation plan. So if we are taking as this fuel example, so mitigation plan should be either in that January onwards, we start implement a quota system and retain our existing fuels and ask people to not to use fuels for unnecessary stuffs, or if you are looking for credit line, or if you are looking for loans, or maybe those so many things, we can build it up as mitigation plan. All what we call mitigation. So so even we identify the risk, we figure it out the criticality and the priority and determine the risk level, and then we figure it out the mitigation. Even risk might be exposed, risk might be materialized. That's exactly happened. So for us, actually, we didn't even identify the risk criticality, or we didn't have a mitigation plan. It materialized. It became once it materialized, we call it the issue. So risk becoming an issue. So after that, we have to build up a contingency plan. What we are going to do? That's what right now we are doing. We are doing a contingency. Once it appeared, we are trying to figure it out or some solution. So ideally, in this entire process, we call risk management. This is a concept. The risk management is a concept we use in any field. First thing is, what we are doing in risk management is we figure it out the risk might happen in future, and then we find out the criticality of that risk. Then we find out the mitigation, and then we will find out if in some case, if this risk appeared, how we are going to attack. So that we need to plan before risk happen, as soon as risk has been identified. This entire process we call risk management. So why I introduced this risk management concept is, in software test, in even quality assurance, even if we are developing our quality assurance strategy, we can use this risk management concept. So that's one of common industry usage. To use this risk management concept to derive the quality assurance strategy, or identify the correct testing types for a strategy. Okay, let's see how we could use that. Okay, we'll take it as a correct real world example, right? Okay. So I'm pretty sure you all has used the fuel pass app, right? So that's one of common thing, right? What we are doing. So this is the fuel pass app, right? So probably you have been used this, right? So what happened is, when the fuel app has been introduced by the ICT in very beginning, what happened? Multiple problems, right?
Yeah, they have not tested load, as well as some use cases, the vehicle numbers.
Yes, exactly.
The chassis number is different for different vehicles, so they have not tested it properly.
Yes, exactly. So the one fundamental issue is
Special characters.
vehicle numbers and chassis numbers are not matched, right? So the functionality is completely not working, right? So then so this kind of app release, so the lot of concurrent users, right? So because people are in the complete pressure, and people start registering, right? Large number of concurrent users could not able to handle. So another thing is, finally it registered more than 5 million users. So that should be expected. So the database has grown, right? So for a 5 million immediately, right? So, and then even that we don't know whether they have tested or not in future. So this is weekly growing, because every week this 5 million has get their fuels. The record will be added to the database. Every week, the 5 million records supposed to be added to the database. So I don't know in next 3 months or 4 months, 5 months time, whether this application even works. Right? So, and other thing is, this application should people start using multiple browsers, many browsers, and multiple devices, different OS, many things, right? And people has a lot of problems, and people start using the multiple network types, right? So some will use the 4G, some will use they are in the home, some will have the different stuffs, and they might use in different conditions, right? So while most of the time, while they are in the queue, they start using while they are inside the car, right? So that signal strengths are totally different. So those are the things, right? So this is problem, right? So if you look, okay, so let's get this case study, right? As a case study, okay. So ideally, this application, if you use the risk management concept for this application, so as soon as this application is developed, or even not prior to develop, but think once at least they have developed, they should have think. So what are the risks? At least risk of this application. So if they have think at that time, what will be the risk of this application? What should they have been find out? So they definitely will find out, okay, if in case this vehicle number and chassis numbers are not good match, it will be a problem. So probably they will figure it out it as a risk, right? In case if this is not matched, then someone has to delete it and re-add it. So then how we are going to delete and re-add it? Or if something went wrong, how this function delete the existing record and re-add it? Okay, that is a risk, right? So they have to think, if we are not allowed delete option, what will happen? So that's a they have to think about as a risk. Okay, so but the other risk is so let's list down while we are discussing the risk, right? The first one of risk is whether this application, so the vehicle number and chassis number, right? Chassis number mapping. I'm just write it very slow. Right, that's the one first thing. So what is the other thing? So if this is not mapping, what will happen? So that's the risk. What will happen? That's the question we need to ask ourselves. So if we are not going to allow delete, if delete option is not available, that's what will happen, right? So the third one, how this application work for maybe large number of concurrent users, right? So that's the other reason. So what else? How this application will for the database large database volume, right? Large DB volume. What else? How this work in multiple browsers. Browser devices. So other thing is how we don't know, right? So how people start hacking this, right? So once they get the 20 liters for their car, if they hack it and get it as the 20 liter, so that's always they have to think, right? How security. Oh, but fortunately, I never heard about that. But if that is also possible, then people will start doing that as well, right? Obviously. So and so other risk is how this align to the government standards or something like that, or kind of. So I'm just listing them down. Right. So those are the risks, right? So we can list it down a lot, but so I'm just listing down. I think very good 7 risks, right? So those are the risks. So what is the criticality of this risk? Critical is if it is appeared real world.
Sorry for disturbing. can we take that multiple vehicles to be registered under same NIC, that one as
Yes,
a risk?
exactly. Yes,
Because
exactly. Yeah, true. Agree. So
it was more critical than this one.
yeah, agree. So
Yeah.
correct. So multiple registration. I just write it down. Yes. So multiple registration, right? So what we'll just look at criticality. I think this vehicle and chassis number mapping is very critical, because if it is not working, it's not working. It's showstopper, right? High. Right? So delete option, it's not too high, because even a rest of even people who, at least people who having registered, they could be able to work it, right? So it's like a medium. Sorry. The multiple registration, that's I think very critical, right? So that's very high. So large number of users, that's obviously we are something expected, high. The large DB volume is even right now we are expecting every week it will grow. So multiple devices and browsers, I think we can consider it as a medium, because at least some device it might work, right? So it might not work for my all devices together, right? So probably it might work at least main devices or main browsers. So probably we can take it as a medium. Security, I think that's very critical, because if some people able to hack it, then everybody will start hacking it and trying to get multiple world orders, right? High. So standards, I think we can omit very, even is standard might be good for government to have their standards, but the people, they might not care much, right? It's kind of a low, right? So you can list it down, risk, criticality. So then as a risk management concept, the next thing is you have to do is mitigation. You need to identify mitigation plan. Okay, what is your mitigation plan? So here, this is what we are going to answer is what question, right? What happened? Vehicle number and test number is not going to map it, right? So avoid that, this feature you have to do the functional testing. Right? You have to do the functional testing for this feature. So next is, again, this is what will happen if we are not providing a delete option. So again, you have to do the functional testing for. So multiple registration is again the what will happen if it's not allowed. So how this application work for the large number of concurrent users? How you going to mitigate? You have to do the load or performance testing. That's how you could be able to mitigate. So large DB volume, so you have to do the volume testing. Multiple browsers, so you have to do the cross browser or cross device testing. Right. Security, so you have to do the security vulnerability, all this testing, right? Let me just write it, security testing. So this is UI testing. So this is how you could be able to mitigate, right? So this is a way you could be able to mitigate. So here, what you have done is, so even if you are doing the software testing, if you want to find a test strategy and testing type, the one of the easiest ways you can list down the risk like this, where this application go on wrong in future. Then you can find out the criticality. Then you can find out the mitigation plan for each risk. This concept, what we use the risk management, and by using the risk management concept and finding out these testing types, we call risk-based testing, right? This is what we call risk-based testing. Okay. So here, okay. So all these testing types we call risk-based. So let me move to the. Okay. So all these testing types, what we identified is different type of testing type based on the risk. So this is what we call is risk-based testing. So risk-based testing is a one of main method what we are using in industry. So to do that, you should be able to have that proper understanding of the application what you are going to do. So they here, if they have done, if this analysis has been done for this fuel app, so they probably these are very few list I listed down. Probably you could be listed down 50, 30, 50, 60 set of risks. If once you listed down all these risks, then you can figure it out the criticality, then you can figure it out the mitigation plan. Your mitigation plan is your test strategy. So then based on the risk, you can plan it. So all the high risk functional test cases, you can run it first. Then you can run all the high risk with non-functional testing. So once you have done all the high risk, high criticality testing types, then you can move to the medium. So then if you have enough time, you can go to the low. If you have done this exercise for the full lab, then obviously they will not release it, right? So if they have done it, at least they will test for the functionality, at least they will test for the security and performance and volume. So then they have done this testing, they will not release the immediate application they have already released, because they will fix it. But right now what happened was they released it without doing this analysis. They didn't do that. Probably they might not have this test strategy. So why they didn't have test strategies? Because they might have tested it, obvious, right? Without having testing, they might not release it. But they haven't used any scientific model. Right? This is the very easiest model that we can use, the risk-based testing. But if that testing, risk-based testing concept, you can figure it out the mitigation plan, and a part of mitigation plan, you will get it out the testing types. So this is exactly test strategy. So in the test strategy, what we are identifying is that then we all with this, if they have done it for the fuel lab, then they will not test, they release, and they will test that features, and they will then fix it. Then what actually happened is they released without testing, and it became a crowdsourced testing. There's another concept, right? I think these kind of application we never can send for the crowdsourced testing. The crowdsourced, we can send application for crowdsourced testing because we need feedback from the crowd. So we are allowing people to test, and we'll gather in their feedback. So these are mission critical labs. We can't go to the public and ask their feedback, right? So we should have built up our own application and this. But there are a set of applications, probably we look for the people feedback. Based on the feedback, we are going to improve this application. So in those scenarios, we go for the crowd. We initially released to the crowd, and once they start using, we will gather the requirement. So, but this kind of application we never use for the crowdsourced testing. So we should have at least, if they have used the risk-based concept, then these testing types have been identified. So am I clear on this, the risk-based testing concept? Any questions? Okay. So let me move back to my slide deck. So that's what we call risk-based testing, and all these risks what we call product risk. So all these application risks what we identified, we will call the product risk. So that's actually what we'll do in part of risk management. So, and what we call the product risk. So there's another type of risk what we call is project risk. So project risk. So these are two different. I'm just going to tell is because sometimes people will get messed up. The product risk, what I listed in for the fuel lab, all are the product risk. Where this application go on wrong, where this product go on wrong. Those product risks we will use to find out testing types. But project risk, we never used to identify testing types. Project risk are something different. So project risk, what we call either organizational, project, political, technical, or supply issues. Like that, the project might not be able to deliver on time. Project might be not properly aligned to the some of the client stakeholders or project might have we might not have competent developers to develop the project, or we might not have the proper business analysis or product owner to manage the product. All these are the project risks. Those will impact in at the end of the quality of the product as well. But these risks will not be going to use to derive the testing types. Only the product risk we are going to use for the derive the testing types. So in this risk-based testing. So risk-based testing is one of common method, and even this is the concept. Even the ISTQB exams they are using. So ISTQB is the world famous and one of key international body for this quality assurance, right? So the ISTQB, even their CBOK, they use the product as the latest strategy that they use to identify the testing types. But still this have a lot of gaps, right? So I don't think this is a perfect solution. But people are still using this because it's easy and it's very clear, it's transparent. So how we have done our testing, it's very transparent, and anybody can gather the feedback from everyone and agree and improve it as well. So that's why people mostly use this concept, risk-based testing. But I'm not thinking it's the one of perfect model. But still, we need to have more matured model. But that's what we actually expecting from the universities, students, and even professionals to do a lot of researches on this. So a lot of researchers still really required to find out the proper model for the derive the test strategy. Okay, that's all about any questions on this? Anything that you have to ask from me? I'm actually moving very fast because I'm covering a lot of areas. But if you have any questions, I think you can throw it to the chat, or you can ask it, or even if you have, you can share it later and try to be able to try to answer. Okay. If you don't have any questions, so there's a small quiz. I think you can scan this QR code and try to answer these questions. These questions actually nothing else but exactly what you have discussed. So I just gave this to make sure that then we can make sure you have been learned this, and at the same time, if you forget what you have discussed, probably you could be able to memorize it and find out the answers. Very simple set of 8 questions as there, that's exactly containing what they have discussed. So you can scan this QR code. So I will keep this quiz open another half an hour, so until 4 p.m. so you can answer. So that's all I'm planning to cover today's session. So from mostly next session we'll work with set of thing on a little bit on other test tools and test automation and some of the testing the quality assurance techniques, so that we can use in next as the next level.
Thank you, Mr. Kapila. If students have any questions, you can ask now. Seems like everything is clear to them.
Yeah. Okay.
And also you're coming in the next 2 days as well, on Saturdays.
Yes.
2 Saturdays as
Yeah.
well.
Yeah.
Yes.
I'll be visiting the university, and probably I think we can have a proper.
Yes. Then you can have more interaction with them.
Yes. Great.
So we can wind up the session now. Thank you so much. I will be uploading the recording so that you can scan the QR code even with the recording, I believe.
Yes. That's good.
Okay.
Great. Thank you very much, Dr. Sani, for giving this chance for us. So let's connect in next time, next Wednesday. Sorry, Saturday on the university.
Yes. We see you on the next Saturday. Thank you, students. I'm going to quit the session now.